this we can find the period of the graph, and then you can get the frequency produced, which is about 150k. And for the frequency divider, we use the 4017, and you can run the frequency divider and check the output waveform. This for Q2. When the output is connected to Q2, the frequency is divided by 2. So we can see the output is divided by 2 from input. Next is 4, and then now is 3, then is 4, and lastly is 5. So we can check that the output is divided by 5. Next is phase outlook, PLL. For this is the circuit for PLL. From this we can see the output of the phase outlook is locked with the input frequency, and for lock range we can find the minimum is 150k, and we toggle the frequency until we get the maximum frequency that lock with the input frequency. So from the simulation we get the maximum is about 500k hertz. Maximum frequency. Next is for capture range, and the minimum range is about 200 kilohertz, and the next is for maximum. Maximum is about 400 kilohertz. So, in order to check the capture range, we put the value outside the capture range. So, for lower than minimum is 190k, we can see the output is not locked with the input. And then, for the maximum, we put higher than maximum, 410k. So we can see here that the output is not locked with the input. Next is frequency synthesizer. So this is the circuit for frequency synthesizer, where we combine the frequency divider and the PLL. So for Q4 with the input 45 kHz, you can see the output is Q5. Output is multiplied by 5. Then Q6, you can see the output is multiplied by 6, which is the output is 240. So for Q7, where output is multiplied by 7, and the output is 315 kHz. And lastly for Q8, where the output is multiplied by 8, and the frequency output is 360 kHz. So for the application, the first part, we take the output of the frequency synthesizer into the input of the transmitter. So the transmitter will transmit the data and the receiver will receive the data frequency. So we can check the received frequency using oscilloscope, and we get the output receive frequency. So next, the second part, where the output of the receive frequency go into the converter, and the converter will convert the frequency into voltage. So we check for the first input, where the input is 225 kHz, the maximum output is 1.54 volt and the LED is the dimmest. And then the second is 240 kHz. The maximum output that we can get is 4.54 volt, and the LED is brighter than before. And the third one is 350 kHz, so the output is about 5.53 volt. We can get a brighter LED than before. And lastly, the fourth one, where the output is 360 kHz. So the maximum output voltage we can get is around 6.88 volt. So the output LED is the brightest.